Okay, I'm going to do the whiteboard to do problem number 17, and there's certainly a pattern to it. You just may not understand what the pattern is at this point. So let's go over here. And by the way, when I'm looking at problems, I don't know what the pattern is either until I look for the pattern. So let me just erase this. It's from an older problem, one we just did. And let's write this down. And what do the terms look like? 1 over 1. What's the next term look like? Well, it's 2 times 1 or 1 times 2. It's 2 factorial. And the bottom is 1 times 3. What's the next one? 3 factorial, which is 1 times 2 times 3 over 135. What's the next one going to be? 4 factorial, which is 1 times 2 times 3 times 4. What goes on bottom? 1357. Now, I'm not going to do this all day long. I just want to get a general pattern for it. So AN. So what's AN going to look like? Well, that's a little bit more difficult. I'm going to say it's, 1 times 2 times 3 times 4, yada, yada, yada. We'll eventually get up to N. All right? We'll eventually get up to N. Now, of course, there's going to be things on the bottom of this, and this is the tough part. What goes on bottom? 1, 3, 5, 7, yada, yada, yada. What goes on the bottom of the last one now? Let's take a look at it. It looks like 2n minus 1. They're going up by 2, by the way. Let's see if this is true. Would you get 1 for A1? Yeah. Would you get 3? Yes. Would you get 5? Yes. Would you get 6? So now comes the question is, does it compare to somebody that's easy to compare to? And I would say, yeah. I'm looking at it, and I'm going to say this is definitely less than something raised to the n minus 1 factors. All right? Let me just see if I got that right. And let me look at that. And let me take a look. I got to think about that. There's n factors here, right? But you know what? I got to clip off that 1 because it's just not right there. It doesn't look like a fraction. The other ones look like fractions. So that's why I said n minus 1. Let me erase this over here. And I'm going to say, let's get my pen back. I am going to say n minus 1 factors. And that's all I'm looking at, these guys over here. The 1 in the beginning, it's just 1. The other ones are definitely fractions, though. Now, kind of looking at it, it's always tough to look at things. I wanted to make it bigger. And the biggest these numbers could become is 2/3. Let me go through that. This is definitely 2/3. This is 3/5. I want to make sure it's smaller than 2/3. Yeah, and everyone's going to work that way. If you did the next one, 4/7, I'm saying it's smaller than 2/3. Yeah, let's do this one over here. And remember, n is a positive number. And I'm going to say you would get 3n, and you get 4n minus 2. And here you get n greater than 2. Oh, this condition needs to be met over here. The n must be greater than 2. All right, so that condition's met if the n is greater than 2. All right, so I feel pretty good about that. And what do I know about that? Well, the series for that, it's geometric, right? If I did this over here, j equals, I don't know, 2 to infinity. Doesn't much matter at this point. But 2/3 n minus 1 is convergent geometric series. So what can I include about this guy over here? Again, this is written as a sum. It's convergent. Again, in the original problem, this was written as a sum. I was just writing the terms down, by the way. It's convergent series, all right? Thank you.